Hi, welcome to projectbazaar.com. The project title is Analysis, Modeling and Simulation of Workload Patterns in a Large-Scale Utility Cloud. The abstract of our project is Cloud Workload in terms of user behavior, task execution, length and resource utilization patterns. The characteristics and patterns of workloads within cloud computing environment is critical to understand. Due to limited availability of cloud trace logs, there is a lack of analysis to support the development of workload models. Here we are proposed a comprehensive analysis of the workload characteristics derived from the prediction cloud data center. The process which is implemented in using the cloud SIM. It mainly focuses on exposing and quantifying the diversity of behavioral patterns for users and tasks. It also identifies the model parameters and their values for the simulation of the workload. The derived model is implemented by extending the capabilities of Cloud SIM framework. Next, the process data flow diagram is first we have to create the cloud environment, that is cloud data center, broker, workloads and number of virtual machines. After that we have to apply the k-means clustering and workload models. Finally we have to evaluate the performance by using the graph. Now I am going to show the demo of our process. The process is implemented by using the Cloud SIM tool. Now we are going to start with start.java. The process is implemented by using the Cloud SIM. For that we have to create the cloud environment. The cloud environments which are data center, broker, cloudlets and VM. First of all I am going to create the data center. That is I am going to create the 3 data centers. Next I am going to create the broker which is an auditor. I am going to create 4 brokers with their ID. Next I am going to create the virtual machines. And finally it is a job provisioning, that is the cloudlets. The cloudlets which is the number of jobs. I am going to give us a 7. Next we have to analyze the load, which are the overloaded and high loaded virtual machines, like that we are going to predict. Next we have to predict the normal kind and speed kind jobs, that is who are the overloaded and low loaded servers, like that. First of all I am going to predict the normal kind of task. These are the normal kind tasks with their parameters, that is a bandwidth, latency, speed, cloudlet length and current load, and also which is similar for normal kind job. Here we are going to predict the speed kind jobs. Here we are going to apply the k-means clustering. For that we have to collect some resources. From that resources only we can predict the k-means clustering and apply the algorithm techniques. For that we are collected the cloudlet ID, virtual machine bandwidth, speed, cloudlet length and execution time, like that parameters we are collected. Next we are going to apply the algorithms. For that we have to analyze the mean, standard deviation and covariance. First of all we are going to predict the mean value. Next step is standard deviation. Next is covariance. Here we are going to clustering the VM. For that we have to collect system into which shows the balanced and imbalanced VMs. Here the overloaded virtual machines which are 5 and 6, like that. The imbalanced systems, these are the these machines which are not possible for the process. Next we are going to predict which are the virtual machines are overloaded based upon the parameters. For each virtual machine we are going to take a parameters, that is a bandwidth, latency, cloudlet length, like that we are going to take. Next is a trace log. Here this is a VM ID and this is the current load for that particular VM and the allocation. We are going to allocate the jobs for these virtual machines. Next we have to Next we are going to show the graph, that is the comparison between the existing and proposed system. First is the execution speed. Here it shows the existing system and the proposed system for the speed, and another graph for execution time. This is for proposed system and this is the existing system. This is evaluated for execution time. Thanks for watching.